Hi everyone. Today we're going to be going over part one of designing servers for a scalable internet. We're going to be talking about some of the basics of servers, what a server is, and why should we care about servers in the internet today. So to start off with, what even is a server? We can think of a server as just basically a normal computer program, and this program knows how to perform a certain task. This may be something like creating an account on a website, loading your social media feed, checking the weather on your phone. All of these tasks that millions of people do every single day are handled by servers. But what makes servers interesting is that while they know how to do all these fancy, complicated things, they don't do anything until someone asks them to do so. So for example, maybe there's a server that knows how to tell what the weather is right now, but only when you open the weather app on your phone does the server actually kick into action and tell you what the weather is. So the natural question that comes from this is, well, who asks servers to do what they're built to do? And in our case, these entities are called clients. So clients are just other computer programs that ask servers to perform a certain action. The terminology that we use is that clients send requests to servers, and servers in return return responses to clients. And so, using the previous example, a client could be a weather app on your phone, it could be your browser on your computer. All these things work by sending requests to servers and then understanding the responses they get back. Now, one thing to note is that servers can talk to many clients at once. So maybe you open the weather app on your phone and someone else opens the weather app on their phone. Both your phones may actually be talking to the same one server. So servers can handle requests for multiple responses at once. And only if there are lots and lots of clients may you need multiple servers. And in general, we call this relationship the client-server architecture, or the client-server model. And the client-server architecture is really one of the most foundational architectures by which most of the internet works today. Over 99% of traffic on the internet is based on this client-server relationship. And that makes it really interesting because almost everything you used at its core is powered by this design. So how does the internet figure into all this? And so as it turns out, the internet is essentially the backbone of the client-server model. Clients and servers communicate through the internet, we say. And you can kind of logically reason about this. So if you open the weather app on your phone, but you're not connected to the internet, you get a message that says, hey, I don't know what the weather is right now, please connect to the internet. And the reason for this is that the weather app on your phone doesn't know the weather. Well, anytime you open the weather app, it actually goes out and it asks the server for the weather because the server is the one who actually knows the weather. And so we see that the internet is really foundational to this client-server relationship. And so naturally, the interesting questions that arise are, well, how does this work? How do clients use the internet to send requests to servers? How does the internet find servers? How does all of this route around and come back to the right spot? Now, to start with, we kind of have to identify servers on the internet. And as programmers, we love to identify things with numbers. So a natural thing that you might come up with is, well, what if we label every server with a number? So every time a new server comes up, we pick a new natural number, 1, 2, 3, 4, 5, and every server is identifiable. So if a client wants to talk to a server, it just has to know its number. In reality, this is actually how things work. The only difference is we use a slightly fancier method that's called IP addresses. An IP address is really 4 numbers separated by dots. You've probably seen them before. For example, 192.168.0.1. And these essentially are the same idea as numbering everything 1, 2, 3, 4. So we assign IP addresses to servers instead of 1, 2, 3, 4 because they have a certain structure and a certain organization to them that the internet internally uses to actually route requests from clients to servers. But really, it's just to help the internet be more efficient. We can think about them for our purposes as fundamentally the same idea as labeling everything 1, 2, 3, 4. Now, while this works, there's one flaw to this approach, and that is that humans are not great at remembering numbers. So imagine if every time you wanted to go to a certain website, you had to type in 4 numbers separated by dots, and it would be a totally different number for totally different websites. So to get around this, we have a system called domain names, and domain names are just normal letters, so maybe like facebook.com, and we use domain names in place of IP addresses, but they map one-to-one to each other. So when you go to facebook.com, in reality, your browser is figuring out, well, what IP address does facebook.com really mean? And then it just talks to that IP address. And you can do this for any website. If you go to this website, for example, this tool, whatismyip.com/DNS lookup, and you type in any website, google.com, facebook.com, whatever you like, it will tell you the IP address for that website. And if you paste that IP address into your browser, you will get the exact same site. The two are absolutely equivalent. It's just that human beings find it much more convenient to use letters like facebook.com or google.com instead of numbers. Now, between domain names and IP addresses, what we're actually doing is identifying computers across the internet. And now remember, if the server's a program, we know that computers can run more than one program. We may end up with a situation where there's more than one server running on one computer. And so what we do is we use a system called ports. So we write here the domain name, and then we put a colon and then a number. And this number is called the port number. Now the port number just says, not only am I talking to the computer, facebook.com, when I get to facebook.com, I want to talk to the specific server that's running on port 8000. And there might be a different server running at facebook.com:4000. We don't typically see these because when you type in facebook.com in your browser, there's typically a default, and it just knows which port to use. You typically don't have to worry about this. But in reality, there is a specific port number that requests have to use in order to make sure they're talking to a specific server. Just facebook.com or google.com will only get you to a computer on the internet. But between domain names and these port numbers, we now know how to talk to specific servers. And that leaves telling the server what we want to do. So once we start talking to facebook.com:3000, there may be a bunch of different things that server knows how to do. Maybe it can log us in or float us our feed. And the way we tell servers what we are asking them to do is with endpoints. And so endpoints, we write them like this. We say the domain name :3000, and then we put a slash. And after that slash, we write what's called an endpoint path, sometimes called a route. And these endpoints are essentially all the different functionality, all the different things that the server knows how to do, and you have to tell it what you're asking it to do. So maybe you're logging in, maybe you're trying to look at a profile picture, a profile named David, maybe you're trying to open Google Drive. Once we identify the server, we have to tell it what to do. But between these three things, we have the domain name, the port, and the endpoint. We have a way of having clients identify servers across the internet, having the internet route the request properly, tell the server exactly what you're asking it to do, and then the internet will return the response from the server back to the client. And that's all there really is to the basics of servers on the internet. Like we said, with domain names, ports, and endpoints, you have everything you need in order to start writing simple clients and servers. And in part 2, we're actually going to explore writing a basic client and a server in Node.js, and we'll see if we can get the two of them to talk to each other and the different type of messages that we can send back and forth. Thanks for listening to part 1. See you guys in part 2.